This is the 4:1 Balun which I homebrewed just now for connecting between my recently homebrewed ladder line and a short piece of HLF 200 cable which goes to the ATU100 automatic antenna tuner. My loop antenna, which is almost a 40-meter folded dipole, in combination with 10-meter long ladder line and 183 centimeter of HLF 200 coaxial cable, was very difficult to tune to 40-meter amateur radio band. It could be tuned easily to 20-meter and 10-meter bands. Difficulty for tuning to 15-meter band was in between. It would not tune to the WARC bands at all. My on-air friends suggested using a 4:1 Balun between the balanced ladder line and unbalanced coax to get a better match. Of course, I have not measured the impedance of the ladder line, and it is likely to be more than 200 ohms and may need a higher ratio Balun. But for simplicity, in my first attempt, I am planning to try out this 4:1 Balun. This impedance transformer had come with an unfed half-wave antenna which I purchased some time back. Somehow, due to mounting constraints, I could not make it work as well as dipole antennas which I had homebrewed. So I decided to dismantle this and use the toroidal core for my 4:1 Balun project, though it is not a good idea to take apart a well-tuned Balun. Measured the outer diameter of the toroidal core and it was about 2.4 inches. So it has to be an FT240 variety of toroid. Though I will not be able to tell what mix it is, I presume that it will be a 43 mix, which is usually used for HF work. Hence, we can call this as an FT240-43 core. FT would stand for ferrite toroid. Went through a lot of write-ups on 4:1 Baluns. Some were using 2 cores or more, while I had only one at my disposal. A video titled How to Build a 4:1 Balun Start to Finish with Mike and Callum on the DX Commander YouTube channel was showing one with a single core, and I decided to follow a simple picture shown on that video. That picture corresponds to the wiring of the Balun shown initially, though the turn numbers are different and my own because of the type of wire I had in stock. That is 6 turns of each color wire on either sides. Took a green 2.5 square millimeter insulated copper wire used for wiring, which I had bought for antenna elements, and anchored one end to the toroid using a nylon tie. This is to prevent slipping on the toroid while winding the wire on the toroid. Wound the green wire on one half of the toroid and secured the other end with a nylon tie. 6 turns could be accommodated, taking into consideration the need for winding another equal set on the same side. Took another yellow wire which seemed to be a bit thicker, possibly because of difference in the insulating layer, and anchored it to the toroid at one end. This will be the second wire for the bifilar winding. Wound the yellow wire on the same side of the toroid so that alternating pairs of green and yellow turns could be seen. While finalizing the winding, initial nylon ties were cut and new nylon ties placed so that the wires would be as near each other as possible. An attempt was made to make the wires at equal spacing as far as possible, though it was not very perfect. A second piece of green wire was wound on the other half of the toroid to get same number of turns and fixed at both ends with nylon ties. In this video clip, you can see that a second nylon tie is partially tightened before cutting the initial nylon tie to get better placement of the wires. Anchoring is now complete and there are 6 turns of each wire on each side of the toroid. Total 4 pieces of wire about 80 cm each would have been used, though I have not measured exactly. Prior to this winding, I had wired a single set of black wire on one half of the toroid and it had measured 120 cm when the wound portion was unwound. But it was slightly thinner wire, there were more turns. I took wires longer than that which were in stock and did the current winding. Ideally, I should have measured the lengths before winding and remaining length after that, which I forgot to do. 2 yellow wires on one side were connected together and that would be the 50 ohms side of the balun, presuming that it will be connected to a 50 ohms coax. On the other side, one green wire was connected to a yellow wire from the opposite half of the toroid. The remaining 2 wires on that side will be the 200 ohms end of the balun to be connected to the ladder line. As per the drawing, the 2 joined yellow wires for the 50 ohm side will go to the central conductor and the green wires for the shield. So the 2 green wires were also joined together on that side. On the 200 ohm side, the free ends will go to the ladder line. Ideally, the next step is to measure the impedance transformation using nano VNA and resistors. But I am planning to try it on the ladder line and see how well it improves tuning on 40 and 15 meter bands. That is because of 2 reasons. One, I do not have a manual tuner, which is the best while using a ladder line. 2, even if this works as an excellent 4:1 balun, that may not be enough for the ladder line, which is also homebrew and of unknown impedance, maybe 450 to 600 ohms. That will need a higher ratio balun like 9:1 balun, about which I am totally in the dark. I wish to thank VU24DX and VU3CDK for their valuable inputs.